class are you coming from? Okay. We're going to go ahead and start off just by looking at a couple of these. You'll find that they're very repetitive, which is kind of nice. Kind of like all the unit circle stuff. Yeah, you kind of will know if you're doing them right or not. So if we look at number 1, I want to move stuff away from theta. So Tucker, put the phone away. And what could we move first?
5.
The 5. So I'm going to go ahead and subtract 5 over. And I should not be able to hear your music, Joel. And I shouldn't see headphones at all because you're being disrespectful. All right. Minus the 5 over. Get out of my room.
Come on, you got anything in the food back, so I ain't gonna keep it out. That's tough.
Go next door.
I'm good.
All right. So how do we get theta by itself? Cotangent inverse, right? So if we think about what the video said, we're using inverses. And that means that we're trying to find an angle. We're trying to figure out which angle on the unit circle where the x-coordinate divided by the y-coordinate becomes -1. The x-coordinate divided by the y-coordinate becomes -1. So where do you guys see it? Everyone should be looking at their unit circle. 3 pi fourths is one of them. There's another one. 7 pi fourths. Okay? So the two answers for this problem are 3 pi fourths and 7 pi fourths. And that's because those are the two places on the unit circle where the x divided by y is -1. Okay, let's look at number 2. That's all you do? Yeah, we solved for theta, right? That's what we were trying to do. Okay. They said in the instructions they didn't want all the answers. We didn't have to put plus 2 pi k. They didn't want everything. They just wanted the answers from 0 to 2 pi. Just the answers on the unit circle. So once we had that, we were done. Okay? All right, number 2, it looks so much worse than it is. So what we're going to do first is we're going to deal with this nasty fraction right here. We're going to split it in 2. So we're going to say -2 plus tan theta. And the way that we split a fraction is we say -6 divided by 3 minus square root 3 divided by 3. So what I did is I said, like, okay, that 3 on the bottom is a common denominator, so I can write 2 different fractions as long as they both have that denominator. Are we comfortable with how I split that? Okay. Can I simplify one of those fractions? Yeah. Yeah, the first one, -6 over 3 is -2. So I'm going to go ahead and rewrite that. And we have a -2 on each side. So what's going to happen with both of those -2's? They're gonna cancel each other out. So if you were like, oh, let me add 2 and add 2, those 2's would go away. So we have tan theta equals -√3 over 2. Sorry, -√3 over 3. That was my bad. Did you guys catch that before?
Yeah, I was just literally writing.
You're like, well, that doesn't make sense. Not for tangent. Okay.
No.
So we know that we're done when we have solved for theta. Not divide by tan. Tan inverse, right? So tan inverse says I'm trying to find an angle where tan of that angle would be -√3 over 3. So we are looking for a y-coordinate divided by an x-coordinate that would become √3 over 3, -√3 over 3. Do you guys remember what point would do that? A y divided by x? Yes. 11 pi 6 would do it. What else would do it? 11, that's a pi, not an 11. 11 pi 6, yep, and then 5 pi 6. So the points the points that would work for this, you have to have a 1/2 as the y coordinate, and you have to have a √3/2 as the x coordinate, and they have to be opposite signs. You can't have positive, positive, you can't have negative, negative. Okay, so the two answers are 11 pi 6, that's where the 1/2 is negative, but the √3/2 is positive. 5 pi 6 is where the √3/2 is negative and the 1/2 is positive.
Oh.
Okay, so two answers for that problem, and then we are done. Okay, I want you guys to go ahead and start working on problem 3. Start working on problem 3 and see how far you can get with it. All right? Okay, so how should you start number 6?
Break it into 2 parts.
Yeah, break that fraction up.
Okay, you still down code.
It's progress though.
Okay.
You get 2.
I made the 4 halves too.
Uh-huh, so that's
Everything
2.
else is the same.
And then from there you can cancel out the 2's and cancel out the 2's.
Okay, why can you cancel out the other 2's?
Yeah, I'm
Because that's
So I'm gonna go ahead and write this. You are right that you can get rid of the other 2's, but you are wrong when you say it's just math.
I don't know.
You can get rid of the other 2's by
When you said if you have to divide it, can't you just flip it?
Common denominator.
we can flip and multiply. So what I would go ahead and do to just get rid of the 2's, you can do that, Brayden, if you want to take care of all of it at the same time. I'm gonna go ahead and just say multiply each side by 2. Because whatever I do to the left side, I can do to the right side. Does that make sense? So 2 and 2 cancel.
So if
2 and 2 cancel. So you're right. The 2's go away, but the reason that they go away is because you multiply by 2 on each side.
On paper, is it wrong?
If you what?
If I didn't write that down on paper, is it wrong?
It's not wrong. You just run the risk of trying to do a shortcut somewhere else where it doesn't actually work. So just be careful with it. So now we have negative square root 3 equals 3 tan theta.
You're going a bit too fast.
Divide the 3 over to the other side of the equation.
Okay.
And then it's negative √3 over 3. And then
Yeah, and we've already solved this.
yes.
Yeah, it was number 2. Okay. What part do I need to go back and explain again? Do I need to?
No,
Or I was just going too fast?
Yeah. Are you okay?
All right. How do we feel about number 7? It's a cosecant problem. Should we look at number 7? Yeah. Okay. Are we good on number 6? Okay. All right. Let's look at number 7. So, what should we do first on number 7? Subtract the 2. Okay. Then what should I do? Okay. Cosecant theta. Yeah, cosecant theta is 2. I don't like cosecant. I can use sine instead. So that would be sine theta equals 1/2. I take that and I flip it, equals 1/2. So now I need to figure out what theta, sine of what. So I'm going to look on my unit circle to see what theta gives me a y coordinate of 1/2. 5 pi 6 and pi 6.
Oh, snap.
Come here, boy.
I like it.
Okay? All right. Keep working. Keep working.
That's right. I got it.
All right. Here we go. So on number 12, you have your variable, your secant theta is your unknown. And you have that secant theta on both sides of the equation. Okay? If we were doing an equation that was just in terms of x's and you had x's on both sides, what would you do with those? You'd move them to one side. If you had them on the right and left, you might take the ones on the right and subtract them over to the left side. Okay? So that's what we need to do here. Do you guys want to subtract 3 secant over to the right side?
Yes.
Or do you want to subtract 7 secant to the left side?
3 to the right.
3 to the right. Minus 3 secant theta. Minus 3 secant theta.
Okay.
So those are gone. And we have negative 11 equals negative 3 plus 4 secant theta. Okay.
Oh, it's so true.
What do you do with that 3? You add it.
That gives you secant theta.
What?
Negative 8 is 4 secant
No,
theta.
No, we didn't.
And then divide by 4. And I don't know about you, but I don't really like secant.
I know.
I like
So
cosine.
turn it into cos. So if it's negative 2 over 1 is the fraction for secant, then what would the fraction for cos be? Negative 1 over 2. Are we done? No. We gotta find the theta. So what angle has an x coordinate of negative 1/2?
2 pi 3.
2 pi 30.
Yes.
Her name is so easy.
Can I just explain what I was thinking?
Yeah.
Alright, no. See, I saw the negative 3 plus 4, and I combined that.
And you had added them
Yeah.
to make it be 1. I got you. Okay. All right. Are we still doing okay?
Yes.
Okay.
But you
So
can keep going.
you'll notice that this entire section we've done so far, 1 through 12, has the instructions where we have to get answers from 0 to 2 pi. It's telling us in the instructions, only look at the unit circle. What happens when we get down to problem 13?
You have to look at
Find all solutions. What did I talk about in the video notes about all solutions? Yeah, plus 2 pi k. You have to have your coterminal angles in there, so you have to think about going around the circle repeatedly. Okay? I'm going to give you guys, how much more time do we want to finish 1 through 12?
Can you go back?
I need like
5 to
10.
10. 5 to 10. Like 5 to 10.
I'm going to go for 5 minutes, and then I will explain to you guys the difference about number 13 and how you do your answer. Now, if you are done with 1 through 12, you can start working on 13, 14. Your solution starting point at least is going to be the same. So get as far as you can, and then I'll help you finish your final answer.
Can you go back?
Okay? Yeah. So we're going to look at number 13. So what's the very first thing you could do to make this problem simpler? Yeah. Add 1. So add 1 right here, add 1 right there, gone, gone.
Wow.
Okay?
No.
So I have negative 2 square root 3 equals 6 tan theta. Divide by 6. So I have tan theta equals negative square root 3 over 3. We have already done this problem multiple times. So what does theta equal for this problem? You've done it for number 2, you've done it for number 6.
11 pi over 6. That's it.
Okay. Do you guys remember what I said in the video about tangent and how often the answers repeat?
No.
I mentioned it in the video. So if this was a cos problem or a sine problem, then for both of these we would write plus 2 pi k and plus 2 pi k. If that was sine or cosine, you can go ahead and write it. It's not wrong. This is totally right. I'm going to show you guys. So if we are picturing a unit circle, there's our circle. 5 pi 6 is over there, right? 5 pi 6 is over there. So this is my starting answer. If I want to get another answer, I can say add 2 pi. That gets me right back to the same spot, right? Add 2 pi, that's another answer. Add 2 pi, that's another answer, right? So that's what it means when it says 5 pi 6 plus 2 pi k. Not only do I have the answer 2 pi 6, but I have all of the answers that are coterminal to that. All the answers that show up in the same spot. Does that make sense? You do the same thing for 11 pi 6. 11 pi 6 is over here. So I'd say 11 pi 6 is my first answer. To find another one, I would add 2 pi k. Well, not 2 pi k, but just 2 pi. Add 2 pi, add 2 pi, add 2 pi. I get the same spot. Different answers. Does that make sense? Now, tangent is the exception to the rule. Tangent, you don't have to add a full circle. Because if you start at 5 pi over 6 and you add half a circle, you get to this one. Does that make sense? And then you add half a circle, you get to a coterminal one for this one. And then add half a circle, you get to the coterminal one for that one. And then add half a circle, add half a circle, add half a circle, add half a circle. Does that make sense? So we're adding half a circle to get to our other answers. So for tangent only, you don't write both of the answers, you just write one. I'm going to go ahead and say 5 pi 6. And instead of saying plus 2 pi k, you say plus pi k. For me personally, when you guys are doing my test, this answer right here is totally acceptable for my test. This answer right here is totally acceptable for my test. They are both right. If you're taking an NCFE and the answer is multiple choice, they will not put this one. They would only put this one. Does that make sense? So for me, when you write the answer in, you're good, you got it. But if it's a multiple choice problem for tangent, they are never going to write both choices. They are going to combine them together and just write one and say plus pi k. Okay? So you just have to know that for the multiple choice problems. If you don't want to write that for the rest of the problems, that's on you. That's totally fine. Does that make sense? Okay, so that's just something to watch out for. Do we want to try another one, or did we kind of understand where we went with that? Do 14? Okay. So, actually, hold on. There's a harder one than 14. Let's go ahead and do you guys want to do 15 or 16?
16.
16.
15.
We're not going to do both. We're going to do 15 or 16. Which one looks worse? 15? Okay. So the dot right there, I think, is a little bit misleading. It's not saying -1/2 times cos. I mean, it is saying that, but that -1/2 is a coefficient. It's saying you have -1/2 of a cos. That's what it's saying, okay? But the first thing I'm going to do is deal with this nasty fraction right here. So what should I do with that? Yeah, I'm just going to separate it. So 4 minus 1/2 cos theta, that stayed the same, equals, I've got 16 over 4 minus square root of 3 over 4 minus cos theta. And what is 16 over 4?
4.
It's a 4. So we have a 4 right here on the left side of the equation, and we have a 4 right here on the right side of the equation, and we can cancel those 4s. Just subtract 4, subtract 4. Those go away. So I've got -1/2 of a cos equals -√3 over 4 minus a whole cos. So I need all of my coses to be on one side. Okay, so do you want to add half of a cos to the right side? Or do you want to add the whole cos to the left side? The second one? Okay, so I'm going to say plus a whole cos plus a whole cos. So I've got -√3 over 4. If I had -1/2 of a cos and I added a whole cos to it, what do I get? I had -1/2 and I added a whole. I have a +1/2. So a +1/2 of a cos. So 1/2 cos theta equals -√3 over 4. How do I get rid of that 1/2? You could divide by 1/2, or what would be a little, you could multiply by 2. So I'm going to say multiply by 2, multiply by 2. So I've got cos theta equals, what happens if I have -√3 being divided by 4, but then being multiplied by 2? What happens with that 2 and that 4? It simplifies to be
Root 3 over 2.
negative root 3 over 2, which makes sense, right? Because that's like the thing that shows up on the unit circle. So it simplifies to be negative root 3 over 2. So we are looking at our unit circle to see where our x coordinate is negative root 3 over 2, which is 5 pi 6, not 11. 5 pi 6 and 7 pi 6. And we are writing all possible answers. And this is a cos problem, so what do we tack on the end?
Plus 2k. I mean, pi k.
2 pi k, 2 pi k.
You're what?
There's our answers.
Did you just say you're mute?
Okay? So at this point, you are working on number 14 and number 16. Working on number 14. All right, so we are going to look at number 17. We are looking at number 17. Are we ready? Okay. So for number 17, we're going to rewrite this problem because they wrote it in math notation, kind of, because they were too lazy to put parentheses. So I'm going to rewrite this. This is negative 1 equals negative 3 times cotangent theta to the second power. That's what that notation really means. All right? So I'm going to rewrite the problem first. Now, I'm trying to get the theta by itself, so what's the first thing I could do? Divide the negative 3 over. So 1 third equals cotangent theta squared. And then what should I do to get cotangent theta by itself? I should square root. And anytime I square root, what should I put in front of my square root? Plus minus. Okay. So on the right side, my squared and my square root cancel.
So cotangent theta.
Mm-hmm. So I've got plus minus the square root of 1 third equals cotangent theta. What do I do with a fraction that's underneath the square root sign? I've got 1 third underneath the square root sign. How do I handle that? You split it apart, the top and the bottom. You call it square root 1 on the top and square root 3 on the bottom. Yeah, you just split them. So square root 1 on the top, square root 3 on the bottom equals cotangent theta. All right, what is the square root of 1? 1, okay. So we have two sets of equations here. I have 1 over square root of 3 equals cotangent theta. That is going to give me 2 answers on the unit circle. I also have negative 1 over square root 3 equals cotangent theta. That is also going to give me 2 answers on the unit circle. So that means I have 4 answers for this problem. So I am looking on the unit circle to see an x-coordinate divided by a y-coordinate that would simplify to become 1 over root 3. What would do that? Not pi 6. Pi thirds, right? Yes, pi thirds, because it's cotangent, not tangent. So pi thirds and 4 pi thirds. So theta here is pi thirds and 4 pi thirds. And then what would give us the negative version? Well, we're thinking cotangent inverse, right? So I did this one. The x-coordinate divided by the y-coordinate would give us this. Now we're going to say the x-coordinate divided by the y-coordinate gives us the negative version. It's not any pi 6. It's not a 6. Pi thirds. So it's going to be 2 pi thirds and 5 pi thirds. So to simplify to be a 1 over square root 3, we were looking for points that had 1/2 as the x-coordinate and root 3 over 2 as the y-coordinate. So to get the positive version, we had to have both points be positive and then both points be negative. To get the negative version, we used the two quadrants where first where you had a negative x but a positive y, and then where you had a positive y but a negative x. Okay? Yes?
When you were over here on the left side, the square root and the two square cancel out, right?
Yes. The square root and the squared. Yeah. All right. Go ahead and work on those. So when you do these problems, for the most part, they should have 4 answers. Because you're always going to have a plus minus. You're going to have 2 answers for the positive version, 2 answers for the negative version.